Let's talk about something that makes a lot of people nervous, the math word problem. But I want you to forget everything you think you know about them. Today, we're not really solving equations, we're learning how to translate a language.
You know that feeling, right? You look at a wall of text, and it feels like you're trying to read a language you've never seen before. It's confusing, it's a little intimidating, and honestly, it's just so easy to shut down and think, nope, can't do this.
Well, here's the secret. You're right. They are a foreign language, a kind of hybrid language I like to call mathlish. And the best part? By the end of this, you're going to be fluent. We're not going to get bogged down in calculations. We're just going to focus on the translation.
Every language has its own rules, its own grammar, and just like the actual Rosetta Stone helped us finally understand ancient Egyptian, we're about to create our own little Rosetta Stone for Mathlish, a way to crack the code from English into these clean, simple math equations.
This right here is the biggest mental shift you have to make. You have to stop reading a word problem for the story, about Mary and her kilograms, and start seeing it as a simple set of instructions that you can translate piece by piece.
So how do we start learning any new language? We build up a basic vocabulary, right? So let's put together a quick and easy dictionary for the most common words you're going to see in Mathlish.
And you'll see it's actually super straightforward. Words like is, equals, results in, they all just become an equal sign. See a phrase like sum of or increased by? That's just a plus sign. Product of or times? A multiplication sign. Oh, and watch out for this sneaky little one, the word of. It almost always means you need to multiply. This right here is our official cheat sheet.
Okay, one last vocabulary word we absolutely need is the variable. Whenever you see a phrase like a number or Mary's weight or the price of a ticket, that's your unknown quantity. It's the whole reason the problem exists. We just give it a simple name, like n for number or x or whatever, just as a placeholder.
All right, we've got our dictionary. Now it's time to actually start speaking the language. We're going to take those vocabulary words and start building them into full, simple sentences or, equations.
Let's start with an absolute classic. A number increased by 7 equals 28. Now remember, don't even think about solving it. Our only job right now is to translate.
We just go piece by piece. First up, a number. That's our unknown, so let's call it n. Next, increased by 7. Our dictionary tells us that's plus 7. The main verb of our sentence, equals, well, that just becomes our equal sign. And the result, 28, is just 28. Easy enough.
And when we put all those little translated pieces back together, we get a perfect, clean equation. N plus 7 equals 28. See? No hard math involved, just simple one-to-one translation. Let's try another one that feels a little more like a real-world problem. 1/2 of Mary's weight is 20 kilograms. Don't let the words fool you. It's the exact same process. So what's the unknown thing we're trying to find? Mary's weight. Let's call it W. Now for the operator. 1/2 of, remember that sneaky of from our dictionary? It means multiply. So that becomes 1/2 times. Our equals word this time is, and then we just assemble the parts. And there it is. 1/2 U equals 20. The system works every single time. Once you know the vocabulary, building the sentence is the easy part. Okay, so we've pretty much mastered basic sentences. It's time to level up. Let's tackle sentences that have a little more complexity, the ones with more than one instruction packed inside. Take a look at this one. The sum of 3 times a number and 7 is 22. Now this sounds way more complicated, but really, it's just a couple of our simple phrases that have been linked together. Don't panic. We just need to find the main idea. So the core of this sentence is the sum of and 7. That tells us the main event is addition. We're adding some stuff to 7. So what is that something? The sentence tells us exactly what it is. 3 times a number, which we already know how to translate. That's 3n. Now we just put it all together. 3n plus 7 equals 22. And there's our final translation. 3n plus 7 equals 22. It looked kind of messy, but by finding that main clause first, even the more complex grammar of math language becomes pretty simple to figure out. The system holds up. Okay, time for our final challenge. We're moving beyond just translating single sentences. Now we're going to translate a full conversation where you have 2 different mathematical phrases being set equal to each other. This one looks like the final boss of word problems, doesn't it? If 3 times a number is increased by 12, the
The result is the same as twice the number increased by 24. Whoa! But look closer. The secret is that little phrase in the middle is the same as. That's our equal sign. It splits this monster sentence into two smaller ones we already know how to handle.
So let's just look at the two halves separately. On the left side of the equals, we have 3 times a number is increased by 12. We know how to do that. It's just 3n plus 12. Now for the right side. Twice the number increased by 24. Again, we've got this. That's 2n plus 24. We just translated two simple phrases. And now, all we have to do is connect them with our equal sign. 3n plus 12 equals 2n plus 24. We took that intimidating wall of text and turned it into one beautiful, perfectly balanced equation. So, to wrap this all up, here is your takeaway translation toolkit. First, always hunt for that equals word. It's the anchor that holds the whole sentence together. Then find your unknown and give it a name. Use your new dictionary to translate the keywords, and then just assemble all the pieces. That's it. That's the whole game. You know, we started this whole explainer by saying that word problems feel like a foreign language. But now, you have the dictionary, you have the grammar, you have the tools to translate them. And this isn't just about passing a math test. This is a new way of seeing the hidden logic and structure inside of a problem. So, I guess my final question for you is, now that you can speak the language, what kinds of problems are you going to go out and solve?